the board. And this is the last section, or at least the online course. We will go farther metaphorically, or go further. I never really know which use to use, further or farther, when you're speaking metaphorically, but you're using the metaphor of spatial distance to talk about like where you're pacing a narrative of a course. Yeah, in the English department, I'm going to ask somebody about that. Because further is a degree of difference, farther is spatial distance. But if you're using spatial distance as a metaphor for the distance in a course where you go between chapter 1 and chapter 4, right? That's not a literal difference, it's a figurative distance. So do you use further for the figurative sense of spatial difference? I don't know, it's an interesting question. I asked that question of my actual physical logic class a few days ago. They were like, what the hell are you talking about? Anyway, it has nothing to do with what we're going to do today. All right, let's take a look at chapter 4.4. And let's see. Oh, here's the share button. Go over here. So in different logical systems, what we start to do is we have three things that we can do to statements here, right? So we have conversion, obversion, and contraposition. Now these, what's interesting here is that, remember, I've talked to you about switching the subject and predicate position. If we do different things to the different propositions, A, E, I, and O, do we immediately preserve the truth value of what we can do? We can do some things to some of these, and then some of these, they don't really work, and some of them they do. So, but what it brings to mind here is, actually, let me not share the book. So like in mathematics, right? If I wrote to you 2 + 3 = 5, right? And then if I were to break these down, like say I say 1 + 1 + 3 = 5, right? I mean, those two things are equal. What I've done is I've just broken down 2 into 1 + 1. But I've written different things here where this is the same as this over here. I've changed the structure, but the content still remains the same. The original truth value of this one is maintained over here. And likewise, if I were to write 1 + 1 + 1 + 2, right? And I broke down 3, so that's 3 and that's 2. That's still equal to 5, right? So there are things that I can manipulate inside the equation, or let's call it a proposition, just because I'm drawing an analogy to mathematics, right? But I could do certain things to some of the propositions and still maintain the original truth value of the original. And so, and I can replace other things with I could replace 2 with 1 + 1, and then I could replace 3 with 2 + 1, etc. Right? And I can still maintain that all of these are still equal to each other because they still generate the sum of 5, right? Now, obviously, we're doing something a little different here. We are doing something, right? So, sorry, that was a message from my fiction editor. So what I could do is I could manipulate the subject and the predicate terms with different things, and some of them will be equivalent and others will be completely changed, right? So the first thing that we're going to do is we're going to take a look at conversion. That's actually the simplest one, right? Conversion is simply swapping the subject and predicate terms in the position, right? So for instance, all dogs are mammals with all mammals are dogs, right? Obviously, the A proposition changes, but I'm going to actually reference the book because it's a little easier to keep track of this with the book in mind, right? So conversion is the easiest of these three operations, that what we can do internal to each different proposition. So what I can do here is, if I said no foxes or hedgehogs, that would be converted to no hedgehogs or foxes. Now this new statement we call the converse, right? Likewise, the obverse and the contrapositive. So to see how these four types of categorical propositions relate to their converse, compare the following Venn diagrams. So if I say to you, all dogs are mammals, and then I said to you, all mammals are dogs, I fundamentally changed the proposition. And a different picture in the Venn diagram corresponds to a complete and utter difference of the original truth value not being maintained. However, note the Venn diagram for both the E and the I proposition, right? So no A or B is equal to no B or A. They have the same picture. So no reptiles are mammals or no mammals are reptiles, same thing. If I said to you some cats are animals and some animals are cats, same thing, right? The picture is the same. And obviously it's the A and the O that do not maintain their truth value. So note here E and I propositions when we switch the subject and predicate term, and that's simply conversion, right? And here's a picture of it, right? So the quantifier stays the same, the copula stays the same, and all you're doing in conversion is switching the subject for the predicate and the predicate for the subject term. Very easy, right? Now, also keep in mind that after the first verb, both the first ones are E and I, right? So that's the second and third vowel of this word are the logically equivalent statements. But we call statements that keep their truth value logically equivalent statements. And later on, what this will mean is that I could take out, in logic proofs, I could take out stuff and replace it with the stuff that's equal to that stuff in exactly the same way as these equations on the board all generate the sum of 5, right? So 2 plus 3 equals 5 keeps the original truth value, even if I take it and I replace it with 1 plus 1 plus 3 equals 5. Same thing, same logically equivalent truth value there. So, and that's the analogy to draw here. So E and I are the same. And maybe I should go out, come back in a little bit to kind of maintain, right, a picture of the screen. There we go. I guess that's probably it. All right. So that's conversion. And conversion is the easiest one, right? Now, in order to understand obversion, all right, obversion requires 2 steps: changing the quality and not the quantity, right? So affirmative becomes negative, negative becomes affirmative, right? So, but the quantity stays the same. So the universal affirmative becomes the universal negative. We're only changing the quality in obversion. And then 2, we replace the predicate with its term complement. And that's basically adding the word non to the P position, right? Okay, let me go out here for a second and let me kind of explain term complements. So the term complement is the technical term for adding non to P, right? So if I were to perform a version on all cats are natives of Earth, right? That's kind of a weird proposition. In order to do obversion to any particular statement, now we know this to be the universal affirmative, right? And the quantity and the quality combine to form their very formal names, right? So we keep the quantity, which is universal, but we're going to change affirmative to negative, right? So the universal negative would become step one, right? No cats are natives of Earth. So you change the quality, not the quantity. So we change this right here. We change that. Now, we also have to add the word non to the predicate term, right? Now, what does that mean? Well, that means just adding the word non to whatever the predicate term might be, right? So no cats are non-natives of Earth. And if you think about that, I know it's really hard to kind of imagine that, but there is no cat that's a non-native of Earth, as far as we know, right? I mean, it's possible there could be cats on other planets, and maybe it's a common evolutionary form, given how big the universe is and how I'm just a speck of sand in an infinite sea of ever-expanding space. But for right now, all cats are native of Earth. So if you say no cats are there's no cats that are non-natives of Earth, that sort of makes sense in relationship to this one. And that's the distinctive feature of obversion. Let's take a look at the picture. You'll see what I mean. And term is just adding the word non to whatever the term complement might be. And so the term complement here would be non-natives of Earth, right? You would keep all the, to see here, all cats are natives of Earth. No cats are non-natives of Earth. They actually keep the truth value. So if you change the quality but not the quantity, and then you add the word non to the predicate, what you generate is every single version of every single mode of an obverse statement preserves the original truth value of the original claim. It's really hard to sort of conceptualize that all cats are natives of Earth. Then there's no cats are non-natives of Earth, because there would be no such thing as a cat that would be a non-native of Earth, because all cats are, by definition, natives of Earth, right? Get my meaning? So, you know, it's a little bit hard to conceptualize a little bit. And if you said no reptiles are mammals, right? And then you said all reptiles are non-mammals, that really makes sense, because all reptiles are non-mammals, because there's never such thing as a reptile and a mammal at the same time, right? So you kind of see it. So I hope that you're seeing this logical relationship, but it's neat. Otherwise, you know, given that when you change, but that also means that anytime if you change only the quality and then add the word non to the predicate position, then you generate logically equivalent statements of any original A, E, I, or O proposition. So, and if you can go backwards too and forwards with this, right? So if you were given no A or non-B, right, and you change the quality and quantity here, you would get all A are B, right? Because you would change the quality, not the quantity. So here's a universal negative becomes a universal affirmative. And here's the other thing, and maybe this is a good time to sort of talk about this. This is the other thing, right? So like if you went no cats are non-natives and you went backwards, right? So let's just write this out as no A are non-B, and then you did the obversion of this statement, which you would change the quality, not the quantity. This would become the universal negative, would become the universal affirmative, and then we'd add a non to non-B. And so we would get no A are non-B. And if this happens, you can think of the nons as sort of canceling out, and you would get, right? And then, of course, you would change this to all, right? And you would get all A or B, which is what we started with, right? But again, if you get two nons, they cancel each other out, and you could just keep the statement letter there. Later on in the homeworks, they won't actually use words. They're just going to use A and B or different letters to stand in for what the predicate or subject term are, right? So they'll just have like a variable that's a stand-in for either the subject or the predicate term. So, and again, if you go backwards and you have two nons, they cancel each other out. And I've told the students, even on the homework, even if they keep the nons, if they have two nons here, they're technically doing it right. But I think it makes more sense to take the extra step when you get two term complements and sort of cancel them out. Sort of like two negative signs. Like if you got -1, you're like, no, that's just one, right? Like you times a negative by a negative, you would get positive. Okay. So keeping your positive and negative signs in algebra correct in really long sequences was always my downfall in algebra, right? I was never an A student in math. I was always like a B or a C student. I could never keep my positive and negative straight. I think that there's just a level of detail that mathematicians have. It's just, if you ever talk to a mathematician, talk to your math professor on campus. They have fantastic minds, right? Anyway. All right, so, right, go back to textbook. So that's Obversion. And then there's something called, and so here's the infographic, right? So change the quality, not the quantity. So some SRP become some S are not. Oh, that's the other thing. Let's mention that. So the other thing is, remember the complement for O propositions is are not, and do not confuse are nots with nons. That can get a little confusing. So take a look at this one right here. Change the quality, not the quantity. So a particular affirmative becomes a particular negative, and then you add the term complement to the predicate position, so that becomes non-B. So some A are not non-B. So do not if you get this little combination here, don't confuse. And remember when I was teaching you the parts of propositions, and I said, remember when I said that in the parts of the propositions, I was like, remember, R naught is technically the copula. This is the reason why. In about 2 or 3 weeks from that position, I was like, in the physical classroom, I was saying like, in my head, like, you don't know this yet, but we're going to add the word non as a term complement. And some students who get confused on obversion, contraposition, and conversion take the term complement non and often confuse the R naught as part of the predicate. And R naught is always the verb, the copula for O propositions. So make sure you see that. And I guess I just needed to point that out even before introducing the next thing that we do. Oh, hello. All right, let's go back to textbook. So you change the quality, not the quantity, right? A becomes E, I becomes O, O becomes I, and E becomes A. And then you replace the term complement in the predicate position with the word non. Now, contraposition has 2 steps. And it's the one that generates logically equivalent statements with the second and third vowel, the A and the O. All right, there's a reason I'm sort of gesturing to this, because in this lecture, I'm trying to kind of like give something kind of unique here about these particular things. So you switch the subject and predicate terms like conversion. So it's kind of combining conversion and obversion and then replacing the subject and predicate terms with their term complements at the same time. So I'm just doing this on the board to like show you later, right? I know that we're looking at the book together. I'm just going to write something down. But all A R B becomes all non-B are non-A, right? Yeah. So And then you see the picture is the same when we do this, right? So we switch B and A and then add the word non to both. That's basically contraposition. If we say, so no reptiles are mammals, it doesn't make any sense because then we would say no non-mammals are non-reptiles. That doesn't make any sense. The picture's not the same, so they're not logically equivalent, right? And then, of course, if we had some cats are animals, then we would say some non-animals are non-cats. That doesn't make any sense in relationship to the original. But if I say to you, some Ford cars are not hot rods, and then I said to you, some non-hot rods are not non-Ford cars, it technically is the same. It might not even make sense because there's a lot of nots and nons here, and you have to think about it for a while. But because the picture is the same, the Venn diagram is working the same in the sense as to like what the sense of the proposition means and how it functions logically, that if this is true, this new version over here is true. And you can kind of see like with the are not, again, with the O proposition, that can get a little dicey, right? So, but I think, let's go back to the board with the first one. I think this, oh, sorry. Where is, right here. Okay, so let's go here to this board, right? So if I have, and so we're talking about contraposition, right? Contraposition, right? You don't do anything to the proposition itself. Only obversion changes the quality or quantity. Well, actually, it changes the quality, not the quantity, but that's the only one that messes with the type. And then basically what you do is you switch the subject and predicate term, and then you add the word non to its new position. So all non-B are non-A. So I just wanted to take this one. If I said to you, all dogs are mammals. I mean, are you tired of that example? I mean, I am, but I mean, I just want to have a common example, right? And then I said to you, all non-mammals are non-dogs. I know it sounds a little crazy, right? But these are equal to each other in this way, right? So that like, if this is true, this is going to be true, even though, now the hard thing with contraposition is we actually don't speak this way, right? We don't actually use term complements. We more or less, you know, and if we use negation, we use it in a more direct fashion than what's being here. But the purpose of this chapter is to show you that like, we can break stuff down, do new things to the propositions, and still somewhat have the same sense of, so technically, if I were in a syllogism and I were to replace all A or B, like all dogs are mammals, with the term complements here, I could still sort of, here's how this would go. So if, say premise one is this or this, and then I said, my mom has a golden retriever that's named Mr. Gibbs. Mr. Gibbs is a golden retriever, by the way. And I say, Mr. And yes, he's named after Gibbs from NCIS, the original one, right? And played by Mark Harmon. So Mr. Gibbs is a dog, and the middle term is distributed at least once, right? Then Mr. Gibbs is what? Is a mammal. Now, if I could technically get this conclusion if I were to erase this and have that there, that still works as an argument in a weird abstract way. I've just replaced something, right? Of course, I would have to do something to these propositions too in order to make sense. But this is technically equivalent to what I just erased. to the point that the syllogism still works in the way that we have been looking at it for quite some time since chapter 1, right? So in a separate video, what I will do is I will go over how these fit together, and we'll do the homework. The homework I can kind of show you right now before actually reviewing, right? Let's go back to the book. But the homework is basically kind of operationalizing these definitions such that, and of course they have charts at the end just in case you forget which keeps its truth value. But you can kind of see here. So if no A or non-B is true and you perform conversion on it to an E proposition, what's the new statement and what's the truth value, right? So, and then you sort of like, you know, so yeah, this is the one we're doing. So this whole chart, the 12 of them, right? And then they give you these sample problems and these operations that you're supposed to do to these, right? And you're supposed to know them. And then you could kind of say like, well, what the truth value is. Now the truth value only here tracks logically equivalent statements, right? There might be things that you just don't know. If you want, just put a question mark there. And then the new one, you're supposed to see what the operation is given what they did to the statements, right? So for number 7, no non-A or non-B, they switch them both and then they do no B or A. So this is another hint. If you have non-nons, you could just kind of write the B, right? But for number 7, hopefully you see what this is. But you know, so what you're supposed to do is you're supposed to kind of see what is being claimed by either the operations or the new operated statement, and then you're supposed to guess what the operation is. And if there's a logically equivalent statement, the truth value is right here. You'll write this truth value over here for the logical equivalent statements, right? And that's kind of like the homework. I think that that'll be a short homework video that we'll do at another time. Just to speak to it, the reason why I kind of pointed you to the second and third vowel positions is I think this is a genius way of kind of proceeding and memorizing what the logically equivalent statements are. So the second and third vowels in conversion and contraposition both correspond to the only 2 statements that actually keep their original truth value. So the E in, you know, and I keep their original truth value in conversion, and then in contraposition, the A and the O are the only pictured ones that have the same picture on both sides, and the E and the I in conversion have the same pictures, right? So they those are the logically equivalent statements, and this is a way to just sort of associate them together. So contraposition has A and O in it; those are the ones, and then the E and the I are also the logically equivalent statements as well. So if you are a little bit confused, and Obversion keeps all of them, right? So those are some replacing stuff with equal stuff kind of lecture. And this gets kind of fun, right? And then we'll do that chart as our homework tracks. And I'll do a substantial number of these together with you, given that there's so much information. And this will be a homework review video in of itself. Okay. All right. So remember, let me stop sharing. Remember, keep thinking logically. And yeah, this is section 4.4, obversion, contraposition, and conversion.